So we did in the previous video, we did some descriptive statistics. Now we're going to actually address our research question, which in this case is there a difference in the mean for our two groups, right? So remember, if we looked at the data here, we have two groups, we have the fours and we have the eights. And they all have a value alpha toxin level. So we want to find the average for the fours and the average for the eights and see if there is a difference in the mean and if that difference is statistically significant. So again, all our tests are under the Analyze tab. So there we go to Analyze and Compare Means, because the t-test is a comparison of means, right? And because these are two different groups, two separate groups, it's an independent sample t-test, right? And so this is what it would look like when you click on that. So you want to remember it's going to be the descriptive statistics. We're going to move into this test variable, right? Because we're comparing means. So it has to be some quantitative value or variable uh, that we use, because we have to calculate the mean for each of those groups, and you can only do that with numerical values. So we would move those values here, and then we want to tell SPSS what is the grouping or the categorization that we're going to be using for this test. And so we move that in here, and now SPSS wants us to say which two groups do you want to compare. Now, in this case, we only have two groups, but sometimes you may have more than two groups, and so you would have to select. If you want to compare more than two groups, now that's no longer a t-test, it's an ANOVA, but we are only doing comparison of two means t-test. T-test means two. And so we do that, and yeah, so that's the basics of it. And so here we have the results of our t-test, right? So we can, you can always double click on that, and you can um, add to the text here. And if you wanted to increase the font or even to change the color, right? In case you have a lot of stuff in your output window. So now we have these three tables. When you do a t-test, you're always going to get these three tables. You're going to get the group statistics, which is essentially a repeat of the descriptive statistics. So you may not need to do the descriptive statistics separately unless there's something you wanted to look at prior to um, doing this. But here you have the means now separated by groups. Previously we found the average of the entire data set, and that was this here, right? Everyone together. This is the average. But when we separated it out, we got two different average values. For the fours, the average is 14.68, and for the eights, it's 8.43. So clearly there's a difference. Now we want to know, is that difference statistically significant? So this is where we go to, this is the main results for our independent samples t-test. So here we have this table, and there's a lot of information here, but we're always going to start, we're going to focus right here for now. So this is your p-value. This is the value that you're going to use to determine whether the results are statistically significant or not, right? And so this value is less than 0.05. So there's obviously that the difference between the two means is statistically significant. So we see that one mean was 14.68 and the other was 8. That the difference between those two, 6.25. 14.68 minus 8.43 will give you this 6.25. So that's the value of the difference, and this is uh, the p-value. If you were to construct a normal distribution curve, then the p-value, this would be what would correspond. Now, this is saying 000 here, but it's been rounded off. If you were to double click on this, it would give you, see, the value is 9.09019 by 10 to the power of -7. Very, very small. So that is our p-value, and therefore we say that the likelihood of these results happening, if HO was true, if our null hypothesis that there was no difference between the means of those two values, then the likelihood of this results happening is infinitesimally small. The probability is very, very low. And as a result of that, we reject our null hypothesis. If the p value is low, then the null must go. And so we have to reject our null hypothesis in favor of the alternative. Now, this is a measure of the effect size, but we're not going to talk about the effect size right now. This is, different ways, that you can measure the effect size. And also, these values here are related to essentially uh, whether the variability between the two groups, whether it's the same or not, and whether there is a statistically significant difference between the variability of the two groups. So remember that when we did our histogram, we could see kind of sort of two distinct differences in the groups here. So this was kind of like group one, and this was kind of group two. So if you did separate um, histograms for each of those, each would have their own kind of distribution and their own standard deviation, just as we calculated here, right? So we see the standard deviation for the group 4 is about 2.6, while that for the group labeled 8 is 3.0, and the mean of each is 0.66, 0.79. Not sorry, the standard error of the mean, or the standard deviation of the standard deviation. So the variance here is relatively the same. So we can use either of these two values, and in fact they're both saying that it's statistically significant, right? So what it's saying here is that the difference is statistically significant. The variance is, for the most part, equal, and so that's what we would report, that the difference between the mean of the two groups is statistically significant. And I'll show you in the next video, when we do a paired t-test, how we would interpret that and how we would report on it.